GKW Physics, I'm Mr. McConley, and today we're going to do a problem which involves work and power. And one of my students in the front row is going to read the problem to you.
A horizontal force of 805 newtons is needed to drag a crate across a horizontal floor with a constant speed. You drag the crate using a rope held at an angle of 32 degrees. A, what force do you exert on the rope? B,
okay, so for A, they're asking what force you exert on the rope. So they told you that to move it along the floor required 805 newtons. But what they're asking for when they say how much force is on the rope is actually this force up here, the diagonal. So in order to do that, it's no big deal. We just have to remember our sine and cosine rules. So in this case, we have an angle, an adjacent, and a hypotenuse, because I've drawn this to be a right triangle. So cosine of 32 degrees is the adjacent side over the hypotenuse. When I do a little calculator work here, I will find that the force is 949 newtons. Is that correct? Yeah. 949 newtons. Then, Lucas, what does B ask us to do?
how much work do you do on the crate when moving at 22 meters?
Okay. How much work? And they also give us a distance of 22 meters. So we're thinking to ourselves, okay, work is force times distance. But what we always have to be careful with these types of problems is to make sure that the force, the distance, and the work are all in the same direction. So which direction are we trying to move this? In other words, are we going to use this diagonal force that we just found, or are we going to use this horizontal force that was given in the beginning? Which way are we trying to move the crate, Joe? Horizontal. We're going to try to move it horizontally. Therefore, these two, force and distance, need to be horizontal. So we're going to take 805 newtons, and we're going to times it by 22 meters, because both of those are horizontal in direction. And when you multiply those together, you get 17,710. Now, what are the units for work? Well, you could say newtons times meters, sure. But most people, since it's work, they would say, oh, that is in units of, everyone?
Joules.
Thank you. Joules. All right, then the last part, Lucas, what does that say?
If you complete the job in 8 seconds, what power is developed?
Time of 8 seconds. What sort of power are we talking about? So power is work over time. And by the way, I can put a box around that. That's a reference table equation. And so is the work equation that I wrote previously. So we're going to take our work number that we just got, our 17,710 joules, and we're going to divide by 8 seconds, which is going to give us 2,214. Now, we could write this as joules per second, but everyone, power is in units of
Watts.
And there we have it for today, physics.